It's your favorite chemistry tutor, Fanju. Now, today we are going to be taking a look at stereoisomerism. Um, I told you in the last class that stereoisomerism is of two types. We have geometric isomerism and we have optical isomerism. Now, I want you to check our previous video on geometric isomerism, under which I looked at E and Z isomer. Now, under E and Z isomer, I looked at an Ingold-Prelog rule that has to do with priority. Now, I'm going to be applying it also on R and S isomer. So, R and S isomer is found under optical isomerism, while E and Z is found under geometrical isomerism. Is that clear? So, I want you to look at that video again so that you can understand an Ingold-Prelog rule that talks about priority given to all our substituents based on their atomic number. I think that is clear. Now, let's start with this R and S isomer. Now, firstly, you should know that compounds that have a chiral carbon are compounds we assign R and S to. That means the R and S is assigned to carbon, to a chiral carbon. So your chiral carbon can be R and your chiral carbon can be S, and meaning that you must be able to identify a chiral carbon. I think that is clear. Now, for example, let's look at this diagram that is here. There's a carbon here, and this carbon is connected to a CH3 that is different from H, that is different from OH, and that is different from Br. So this carbon at the middle is a chiral carbon. I just quickly give you a recap on the chiral carbon. A chiral carbon are sp3 carbon. You can see a single bond, single bond, single bond, single bond. Then our carbon is at the middle. This is different from this, is different from this, is different from this. That is a chiral carbon. So R and S is assigned on chiral carbon or chiral center. Is that clear? Now, another thing I have said again is that for you to understand R and S isomer, you must remember your CIP rule, can Ingold-Prelog rule. I think that is clear. I'm going to do that here also. Now, another thing we should pay attention to is this. Before or any question that will be given to you, and they will ask you to assign maybe your R or S, that question, that formula is either written in a Fisher's projection or they write it in a 3D using wedge and hash. So meaning that anybody giving you question to determine if it is going to be R or S should either use a Fisher's projection, or if the person is not using a Fisher's projection, the person will use a 3D. So I'm going to give you a question that has to do with Fisher's, then we are going to look at questions that have to do with what? 3D. Now, this course is mainly for 200 level students, peculiar to 200 level students and above. And for those who are in chemistry, pharmacy, pharm chem, biochem, and many other departments offering chemistry 200 level. So, CHM 202 and PharmChem 202, like I remember. Now let's go back to it. So I said if they ask you to assign R and S, they must either write it in a Fisher's projection or they write it in a 3D manner formula so that you can assign your R and S. So how do we go about it on a Fisher's projection? Very simple. How do we go about it on a Fisher's projection? Let me teach you. Now, how does a Fisher's projection looks like? Now, in a Fisher's projection, we have vertical and we have horizontal. Vertical and we have horizontal. Now, listen. The vertical line, we assume that the vertical lines contain elements that are pointing away from us. For example, if you take a look at me, the way I'm standing, all you can see about me is this dimension and this dimension. That means you are seeing me in this place in a 2D. You are not seeing my back. If I'm standing this way, is that okay? Because human being sight is limited. You can only see. If I ask you to draw me the way I'm standing, you can only draw me here. You can't draw my back. Is that okay? So our molecules exist in 3D. Molecules ideally exist in 3D. There are some pointing towards you, and some pointing upward, pointing, and there are some pointing at the back. Is that okay? So in a Fisher's projection, any guy that is on the vertical line means they are pointing. The ones on the vertical line means they are pointing towards the back. They are going towards back. While the horizontal means they are pointing towards us. Vertical to the back. Horizontal is pointing towards us. I think that is clear. Thank you. Now, the same thing with this. Now, I want us to attempt this question. The rule is, firstly, you must remember your Canning-Gold pre-log. So I'm dealing with Fisher's projection alone now. So the first thing when you see questions like this is this: you assign your priority rule. What I say you do, you assign your priority rule. How do we assign priority rule following Canning-Gold pre-log rule? You give them the one that has the highest atomic number. Now, Br, this is bromine directly attached to this carbon. There's a carbon at the middle here that is not revealed. This is Fisher's projection. So bromine, oxygen is directly attached, hydrogen is directly attached, and carbon is directly attached here. So bromine should be given priority number one because it's bigger, followed by who? Followed by oxygen, which is atomic number 8, followed by carbon, atomic number 6. Then lastly, who? Hydrogen, atomic number 1. So who is giving the highest priority here? According to Canning-Gold pre-log, Br, bromine. I think that is clear. Now, the next thing is this: you will connect your 1 to 2 to 3. What am I saying again? You connect 1 to 2 to 3. You see the 4, just assume, cancel the 4 as if it's not there. Is that okay? So we are connecting our 1 to 2 to 3. We are connecting our 1 to 2 to 3. Now, if you connect 1 to 2 to 3, it can either go in clockwise or anti-clockwise. If it is clockwise, we say it is R. If it is anti-clockwise, we say it is what? S. But there's a rule that you must follow. The rule is that anytime you want to apply, maybe you want to count R or S, you must ensure that the lowest priority. Who can tell me? Bromine, OH, hydrogen, CH3. Which of them is having the lowest priority? Hydrogen. The lowest priority, which is hydrogen, must always be on the vertical line. Vertical line, like I told you, means is pointing away from you. It is pointing towards the board, away from you. And I told you vertical means is pointing towards you. Horizontal means is pointing towards you. Vertical means is pointing away from you. So the rule says that the lowest priority must be pointing away from you, meaning that in case of Fisher's projection, it should be on the what? On the vertical line. Now, if you look at our hydrogen, is appearing on where? Everybody is appearing on the what? Vertical line. Because it's appearing on the vertical line, I'll leave it this way. Now, then I will now connect my 1. You can see the 1. I'm connecting 1 to 2. Then assume this one is not there. So 1 to 2 to what? 3. Now, if you see this way I'm going, is it clockwise or anti-clockwise? Clockwise means you are going in the manner of the clock. So this is clockwise. You are going in the manner of clock. But if you go this other way, this is an anti-clockwise means you are going against the hand of the clock. The hand of the clock move, and see, it is clockwise. Clockwise. So this is clockwise. 1 to 2, then to 3 is clockwise. And anytime it is clockwise, if it is clockwise, then S, if it is what? Anti what? Clockwise. Now, in this case, we are going in the clockwise manner, and our hydrogen, which is the least priority, is already on the vertical line, pointing away from us. So I can vividly see that this guy is R, this carbon here is an R isomer. That means this compound is R isomer, this chiral carbon is assigned R. Now, let's go to this guy. Now, what do you notice about this Fisher's projection? You should be able to do this now. Firstly, you notice that our hydrogen was not on the vertical line, meaning that it's not pointing away from us. It's on the horizontal. And I told you horizontal means it's pointing towards you. But the rule says that hydrogen must be pointing away from us. It must be on the vertical line. Now, in this case, it's not on the vertical line. What do we do? Let's first assign. So let's assign. Oxygen, we have oxygen, carbon directly attached, hydrogen directly attached. In this case, oxygen is given priority number 1. I think that is clear. Why? Because oxygen is having atomic number of 8, carbon is having atomic number of 6, and I think you are clear with that. So this is giving number 1. Now, oxygen is having a bigger atomic number. So that's why I'm giving it 1. Now, but this carbon and this carbon is the same thing, because what is directly attached to this guy here is carbon, and what is directly attached to this guy here is carbon. So there's a tie. Tie means there's a draw. And if there's a draw, I think I told you when I was taking you E and Z, what you need to do. In this case, we have C, H, we have H, we have H. That's what we have in this case. Why in this case we have C double bond O, abi C double bond O OH. This is what we have for this one. Then this is what we have for this one. Now, since this carbon and this carbon, which is this one and this one are the same, that means there is a tie. If there is a tie, what did I tell you? In Canning-Gold-Taylor group, once there is a tie, you move to the nearest element that is attached. So meaning that this carbon here and this carbon here, they are the same. Meaning this one here and this one here is playing a draw, is a tie. So meaning I have to move to the next thing. So what's the next directly attached to this guy? Firstly, what is directly attached to this my carbon? Can you see this carbon is what? Oxygen. O. Now, double bond O. Do you remember I told you anytime you are dealing with Canning-Gold-Taylor group, if you have double bond to element or triple bond to element, you should know what will happen. If I have, for example, C double bond O, it means that my oxygen is going to be 2. If I have C triple bond N, it means my N is going to be how many? Tripled. I think I explained that in the last lab. If I have C double bond C, it means that the C that will be here will be C, how many C? 2C. So in this case, this carbon is attached to O, oxygen. This carbon is attached, is now double bond O, meaning it's going to be what? O and O. Is that clear? O, then double bond O, O. This is attached to O. Double bond O means O and O. I think that is clear. Now, let's move to the next one. In this case, in this guy here, what is this guy directly attached to? Is directly attached to hydrogen, which is H, and H. So, before now, these two guys they are playing draw. It is a tie, carbon and carbon. There was a tie. So I have to move to the next thing. So oxygen, 2, double bond O, that's 2, with this oxygen making 3. But in this case, our carbon here is attached to hydrogen, that's H. Is that okay? So which of them is having the highest priority? This guy or this guy? Now, this guy is having more priority than this guy because this is oxygen and this is hydrogen. So I can vividly say that this guy will be number 2. Why this one? Everybody. This one will be number what? Everybody. This one will be number 3. And this guy here will be number what? 4. I think you know the reason why I gave this number 2, even though it is carbon. I've explained that to you. Now, in this case now, we have 1, we have 2, we have 3, we have 4. And I told you that how do we go about it every time? You connect 1 to 2, then you now connect it to 4. So how do I connect 1 to 2? This is 1 connected to 2. Can you see that this 1 is connected to 2? Then now connected to 3. Now, is it going clockwise? This is 1 straight down connected to 2, then connected to 3. Now, in this case, am I going clockwise or anti-clockwise? I'm going anti-clockwise. Anti-clockwise means it's going to be what? S. Anti-clockwise means it's going to be what? S. The answer is going to be S. Why? Because I'm going in an anti-clockwise manner. But my answer is not going to be S. You know why the answer is not going to be S? The reason is because I told you that the lowest priority, which is the number 4, should always be on the vertical line. But in this case, is it on a vertical line? No. Because it is not on a vertical line, what then do we do? Very simple. Because it's not on a vertical line, the answer we got was anti-clockwise, which is S. Then you will change the answer, you reverse the answer to become what? R. So the answer to this question is R. So anytime you're in a Fisher's projection, anytime the lowest priority, the one that is the lowest priority, that means the number 4, is not on the vertical line, what do? You get your answer, then you now reverse the answer. So in this case now, we left it like this. When we got our answer, the answer was giving us S, and I said the final answer will not be S, it will be R. We changed the S to R. The reason why we changed the S to R was because hydrogen was on the horizontal instead of vertical. If hydrogen was on the vertical, we'll leave the answer. In this case, when hydrogen was on the vertical and we counted and it gave us R, the answer was R. I didn't alter the answer. But in this case, the hydrogen was on the horizontal. So what they have to do, have to ensure that after getting my answer to be S, then we reverse the answer to be what? R. I think that is clear. Now let's move to the next one. We are going to be looking at our 3D. I think that one is clear on Fisher's projection. So let's move to the next one, which is the what? 3D, wedge and hash. Let's move to the next one. Take a look at this. From where we stop, we are still on R and S, but in this case, we are not going to be looking at Fisher's projection again. We want to take a look at using wedge and hash, which is more like your 3D. Now, some of you are not conversant with this wedge. Anytime you see a wedge, this is the way the wedge looks like, this black wedge. Now, um, wedge means the element on it is pointing towards you. It's pointing towards you. Why hash? Anytime you see hash, hash means the element is pointing away from you. So for example, a part of me like this is pointing towards you, while a part of me is pointing away from you. That's my back. Is that okay? So anytime you see a molecule drawn this way, what you think of is that this chlorine that is having a wedge means that this chlorine is pointing towards you. It's pointing towards you. Chlorine is pointing towards you. Is that okay? So anytime you see wedge, just know that that molecule must also have hash, because we are indicating the 3D structure of that molecule on a paper or a board. Now, for example, now we can see that this is having wedge. Because it's having wedge, wedge means that my chlorine is pointing towards, this chlorine is pointing towards you. So it's having a wedge. If it is having a wedge, if this molecule is having a wedge, it should also have a hash. Is that okay? Provided that if you look at it, there's a carbon here, and this carbon is already having a plane, and a plane is having a wedge, then it must also have a what? Hash. You can see that the hash is not indicated, but I know where the hash is. So far, we already know that there's a wedge on this carbon. If there's a wedge on that carbon, there should also be a what? Hash, of which I'm going to indicate that. Now, don't forget again, wedge means it's pointing towards you. Wedge means it's pointing towards you. While hash means it's pointing into the board, away from you. Is that okay? So now, in this case now, this is and I want us to, this is a line formula for those who do not know. You should know that this space means CH3, this space is CH2 for those who do not know. Then this space is CH3. Yeah, it's a line formula. Then there's a carbon here. Now this carbon is attached to this carbon, it's attached to this carbon, then it's attached to chlorine. So if it is that, you know that it is not complete. 1, 2, 3. You know, anytime we are dealing with R and S, the carbon will be dealing with should be a chiral carbon that must have 4 substituent around it, meaning that there should be, this is one bond, 2, this is another bond, making it 3. Then there should be a fourth one. It is that fourth one that is, because most of the time they write it this way, they just don't want to indicate the hydrogen. Is that okay? Now there's a wedge here. I mean, since there's a wedge here, then we'll have a hash, because there's a wedge on this carbon, there will be hash. Now, who is on this hash? Because if you leave it this way, it means there's a carbon there, but what we have here is hydrogen. I can now say 1, 2, 3, 4. I think that is clear. Now look at this one also. I just want us to first analyze it, then we'll solve the question. Let's look at this. This is CH3, in case you don't know. This is CH3. I mean, sorry, that would be CH2. This is CH2. This is CH3, CH2. Then this end is also a CH3. I think that is clear. Then if you look at, where's our chiral carbon? You know that this cannot be a chiral carbon. This cannot be a chiral carbon because you're having hydrogen attached to the identical element attached to the carbon, identical. So this is the only chiral carbon that we have there. Is that clear? Now, if you look at this chiral carbon now, it's already having a hash to OH. I told you that if you have a hash, there should be wedge. If you have a wedge, there should be hash. Now, we have one bond. This is the carbon at the middle. There's a bond here. There's a bond here, making it 2. This one making it 3. So there should be a fourth one. Sorry, if this is hash, then there should be a wedge. Now, and in this case, you can see that this is, we already have our wedge and we have a hash. Now let's quickly look at how we can assign R and S to this quickly. Now, very simple. Now, firstly, like we normally do, we assign priority. Then don't forget, I told you something, that the lowest priority, most of the time hydrogen is always the lowest priority, but any other element or substituent can be the lowest priority. The lowest priority, I mean that number 4, the number 4 should always be pointing where? Away from you. In the case of Fisher's projection, I told you that vertical means any guys on the vertical means they are pointing away from you. So in the case of 3D where we are using wedge and hash, wedge means it's pointing towards you, hash means it is pointing away from you, meaning that your number 4 should always be on the hash. Your number 4 should always be on the hash, which indicates it is pointing away from you. Now let's take a look at this first molecule. This is our chiral center. Now where is the hash? Is the hash, and who is there? Hydrogen, which is going to be the least priority. I'm going to put priority on there, but hydrogen will be the least priority. You can see that this is okay now because hydrogen is on the hash, is the least priority. Now let's give priority to them according to Kahn-Ingold pre-log group. Is that clear? So chlorine will be number 1. Why? Because chlorine have, this is the carbon we are looking at. So 1, 2, 3, 4. Chlorine will be number 1. The atomic number of chlorine is greater. Then we have carbon here that is attached to H, that is attached to H, that is attached to H. Then, so that is carbon. Then this is carbon. This place is also carbon. We have carbon. You can see that there's a tie here. There's a carbon here and there's a carbon here. So if this is number 1, who will be number 2? This or this? There's a tie. So what do we do in this case where there is a tie? Very simple. I told you that you go to the next thing. Now, if you look at this carbon, what else is directly attached to this carbon? We can see hydrogen, comma, hydrogen, then what? Hydrogen. But let's go to this this guy that is there. This guy is C, attached to H, attached to H, then attached to C, attached to H, H, and H. Do you agree with me? So what is directly attached to this our carbon? Who can tell me? We have what? H. We have what? H. What else we have? H, H, then directly attached was C. So in this case, we have C, H, H, and the other one we have H, H, H. Who among them should be given more priority? HHC or HHH? Because this have carbon, this we have more priority than this guy. So meaning that this is number 1, this place will be number 2, then this one will be what, everybody? Number 3. Then hydrogen will be number 4. Now you can see that the least priority, which is number 4, is already on the what? Hash. Because it's already on the hash, it's making sense very well. So how then do we count? Very easy. Now I told you that you connect your 1 to 2 to 3. You ignore the 4. So where is the 1? Can you see 1? 1 to 2. Ignore this 4. Then to 3. Now 1 to 2 to 3. Are we going clockwise or anti-clockwise? I need someone to give me that. Going this way. Is it clockwise or anti-clockwise? If you are going this way, you are going anti-clockwise. You are going against the hand of the clock. See. So in this case, it is anti-clockwise. And anytime it is anti-clockwise, what do we call it? S. Now the final answer is S, and I'm not changing the S to R. Why am I not changing the S to R? I'm not changing the S to R. Why? Because number 1, our hydrogen, which is the least priority, is already on the hash. Now, I think that is clear. I want us to do the same thing on this guy. Very simple. Who is giving the priority? Let's really give priority to them. Priority. Oxygen, we have CH3, we have hydrogen, and we have carbon there. Now, what do you notice about this case? In this case, our hydrogen was not on the hash. Our hydrogen is on the wedge. Because our hydrogen is on the wedge, what do we do in this case? I need somebody to give me answer to this. Very simple. Very simple. What do we do? Let's give priority. This is priority number 1. Followed by who? I already did between this. This is methyl, and the whole of this like this is ethyl, and I've already explained to you the way I got the answer. So if this one is 1, this space is going to be 2. I explained it there. Then this space is going to be what, everybody? 3. Then this space is going to be what? 4. Now, don't forget that hydrogen was not on the hash in this case. Hydrogen was on the what? Wedge. But let's count. Let's count. So where's my number 1? This is number 1. So I'm connecting 1 to 2 to 3. Don't forget. Ignore 4. 1 to 2. So this is 1. Connect it to what? 2. And connect it to what? 3. So what am I in that direction? Is it clockwise or anti-clockwise? If you are going this direction, it is what? You can see. It is clockwise. Because it is clockwise, it should have been what? The answer should have been what? R. But our answer will not remain as R. Why is the answer not remaining as R? The answer is not remaining as R because Very simple. Who will tell me? It's not remaining as R because hydrogen was not on the hash. Hydrogen was on the what? Wedge. And because it's on the wedge, what do? We change the answer to what? The answer that we have here was R, which is clockwise. But because the hydrogen was not on the hash, which is the lowest priority, it was on the wedge, we change our answer to the what? S. Very simple. Now, I want us to try this last question. This last question is tricky. Why? The reason is because our hydrogen was not on the wedge and was not on the hash. In the first case, hydrogen was on the hash, which is correct. In the second case, hydrogen was on the wedge. And I told you that if the hydrogen is on the wedge, the answer you have to invert your answer. You can see. But in this case, hydrogen is not on the hash and is not on the wedge. What you do in this case, very simple, is different from these two scenarios. What you do in this case is that you take this hydrogen here, you swap it with the other one that is there. You swap it. When we swap it, we are going to have something different. We are going to have, for example, let me do this for you. Because here our hydrogen is not on the wedge and on the hash. Is that okay? So we have to swap the hydrogen with another guy that is on the, in this case I didn't swap it, I left it this way. Is that okay? Because hydrogen was on the wedge. So the scenario is here is hydrogen was on the hash. We left the answer like that. Hydrogen was on the wedge. We got the answer to be R, then I invert the answer to S. Why? Because hydrogen was on the what? Wedge. But in this case, hydrogen was not on the hash and was not on the wedge. So in this case, what we do is this. We take this hydrogen and swap it with the one on the hash. So if I were to redraw this, it will look like this. Now, you can see that it is hydrogen that was here before. Now, I'm going to swap it, and what we are going to do now is we have CH3 here, we have hydrogen here, we are going to swap them to each other. We now have hydrogen here, we now have CH3 here, then OH remain. We can now apply our parity. You know that this guy is number 1, then this guy is number now if you look at this compound and this compound are not the same again, because I took the hydrogen that was here, I swapped it, so that now my hydrogen is on the hash. Is that okay? So let's continue. So I have 1 parity 1 followed by the guy that is here. This is CH2 CH3. This guy is our number 2 and this is always number 3, and this guy here, our hydrogen, is in number 4. So if I'm to move 1 2 3, you know the way we are going. This is 1 2 3, 1 to 2 to 3. Now, is it clockwise or anti-clockwise? Going this way, is it clockwise or anti-clockwise? Clockwise, which is R. So the answer should have been R. Now, the reason is that we've altered this molecule and we got R. Is that okay? Now, if the answer we got here is R for the altered molecule, what would have been the answer that would be here? So the R that is here will now be what? S. So please go over it again. Because of this video, I don't want it to be too long. I want you to go over what I did. The first scenario, what happened is that our H was on the hash. In the second one, our H was on the wedge. When H was on the hash, we got our answer straightforward. You can see that this molecule was going in anti-clockwise manner. Now, in this case, our molecule was going in the clockwise manner, which should have been hard, but I changed the answer to S. Why? Because the H was on the wedge, not on the hash. I didn't interchange them. What I did was that I left it like that, got my answer to be R, then I said R has become S. But in this case, my H was not on the wedge and the hash, so what do I do? I said, you swap it with the guys on the hash. So CH3 was on the hash, I swapped it, so I put CH3 here, then H there. So then I put parity on them, then we go on, we counted from 1 to 2 to 3, which is hard. Because this answer was hard for this molecule we have altered, then this answer for this molecule would have been S. Now I'm going to drop a question on the caption to try yourself. Ensure you try those questions. Is that okay? Now, thank you so much. If you have more questions, you can ask in the comment section. You can ensure to engage our channel, like and follow. Thank you so much. And